For months, astronomers around the world had been waiting. From the snowy ridges of Chile to the steel-blue observatories in Hawaii, every telescope was aimed at the same silent traveler drifting toward the sun. Its name was 3I/Atlas, an interstellar visitor, older than the planets themselves, crossing the thin line between the deep cold of space and the heat of our solar fire. It wasn't the first object to pass through our system, and no one expected it to be anything unusual. It was supposed to be simple: record the data, measure the light, watch it pass, and move on. But when the first light curve arrived, something was wrong. The numbers didn't fit the model. The brightness didn't fade the way it should. Instead, it pulsed, steady, rhythmic, precise. At first, the scientists blamed the instruments. A calibration issue, maybe an atmospheric glitch. But every time they rechecked the data, the pattern returned, identical, exact, as if written into the light itself. In the quiet of the control rooms, people stopped talking. Screens glowed in the dark as hands hovered above keyboards, unsure what to type. The rhythm of the light seemed almost alive. One researcher described it in her notes: "It feels like it's answering something." That line never appeared in the official report, but it spread quietly among colleagues, shared in late-night messages, whispered in the hallways of observatories around the world. Normally, a comet or interstellar rock brightens as it approaches the sun, then fades as it begins to evaporate. But 3I/Atlas did the opposite. It grew brighter, far brighter than any physical model allowed. Its reflectivity nearly doubled within days. Spectral analysis showed materials that shouldn't exist together, volatile ice mixed with something that reflected like polished metal. It wasn't acting like a natural object. It was responding to the light, shaping it, bending it back with deliberate precision. And that was when people began to feel it, a strange awareness behind the data. The graphs on the screen no longer looked random. They looked intentional, almost communicative. Some scientists dismissed it, saying the mind is wired to find patterns even where none exist. But others couldn't shake the feeling that the numbers were trying to say something. At the European Southern Observatory, one astrophysicist ran the pulse intervals through a computer model and froze. The ratios matched a sequence of prime numbers, the kind of structure nature almost never creates by accident. When she shared it privately with her team, no one spoke for several seconds. Finally, someone said, half joking but not really, "So, what are we looking at? A rock, or a message?" No one dared to repeat that outside the lab. Science has rules, and one of them is that you don't jump to conclusions. But the data kept coming, and the data didn't care about rules. Each night, more telescopes joined the effort. Amateurs uploaded images, comparing the brightness changes in real time. The rhythm was the same no matter where it was measured, the same clean, repeating pattern echoing across half the planet. There was no natural explanation that fit. It wasn't tumbling. It wasn't venting gas. It wasn't random. Then came the velocity report. 3I/Atlas had slowed down. Only slightly, but enough to measure. Nothing in the sun's gravity could explain it. There were no nearby planets to pull it off course. Somehow, it was adjusting itself. As if something inside it was alive, or aware. No one said those words out loud, but they hung in the air like static. It felt as if every new piece of data was quietly rewriting what people believed about space. The object that was supposed to be a frozen relic from another star system was starting to look more like a visitor. A senior astronomer in Pasadena wrote a single line in her personal log that night: "It feels like watching an animal breathe." She deleted it before sending her official summary, but the thought stayed with her. By now, the object's surface was reflecting so much light that instruments had to recalibrate just to track it. It was as if the object wanted to be seen, or couldn't help but be. Some began to wonder if it had always been there, traveling through the dark for eons, waiting for this exact moment to reveal itself. Still, the official explanation remained cautious. Reports described anomalous reflectivity and unexpected periodicity. But inside those dry technical terms was the quiet acknowledgement that something about 3I/Atlas didn't belong to our understanding of nature. As it drew closer to the sun, the pulses became faster, more deliberate, like a countdown. The rhythm that once felt distant now seemed urgent, almost emotional. Scientists compared the timing to its orbit, its rotation, the solar radiation it received. Nothing matched. The light had its own logic. When the final data set of the week came in, the room fell silent. The curve rose and fell in perfect intervals, like a voice speaking through brightness. One researcher whispered, "Maybe it's not reacting to us, maybe it's reacting to the sun." The thought spread quietly. If 3I/Atlas was communicating, maybe it wasn't speaking to Earth at all. Maybe we had just intercepted someone else's conversation. By the end of the week, an official statement was released: unusual fluctuations detected in the light curve of interstellar object 3I/Atlas. Investigation ongoing. That was it. No theories. No answers. But those who had seen the raw data knew there was more to it. The pattern wasn't fading. It was growing stronger. Outside the observatories, the night sky looked unchanged, stars scattered like dust, the faint band of the Milky Way stretching overhead. But for those who had watched the numbers dance on their screens, the sky no longer felt silent. It felt aware, like something vast and old had just opened its eyes. And as 3I/Atlas moved closer to the sun, the question deepened. Was this just another comet on a path of ice and gravity, or was it something else? Something that knew we were watching? No one could say for sure. All they could do was wait, and keep looking up, into that endless, waiting sky. It started as a whisper in the data, a flicker so small that most instruments would have ignored it. But it wasn't ignored. Because by now, 3I/Atlas had everyone's attention. Every telescope, every satellite, every scientist who had ever looked up at the night sky, they were all watching. At first, the readings looked like random static. Background noise from the sensors. Nothing unusual. But as the data kept coming in, the noise began to take shape, and then, it began to repeat. Every 7.2 seconds. Over and over again. In Chile, an astronomer leaned back in her chair, staring at the monitor as the pattern formed, a slow, deliberate rhythm pulsing through the darkness. Thousands of miles away in Hawaii, another team saw the exact same thing. Their instruments were different. Their atmosphere was different. But the signal was identical. No matter where on Earth it was observed, the light from 3I/Atlas beat like a clock. It didn't make sense. Nothing in nature behaves that precisely. Comets don't flash in perfect intervals. Rocks don't shine with intention. But here it was, a cosmic heartbeat, steady as time itself. At first, the teams thought it might be an equipment glitch. A syncing error. Maybe their systems were picking up interference from satellites or radar. But as they compared data between observatories, from Chile, Hawaii, even the frozen silence of Antarctica, they found the same rhythm, repeating without fail. 7.2 seconds. 7.2 seconds. 7.2 seconds. The pulse continued, unwavering. Some called it the object's rotation. Others called it coincidence. But deep down, no one could ignore how unnatural it felt. Even the silence between the pulses seemed heavy, like the space between heartbeats in a moment of fear. Across message boards and encrypted channels, astronomers began sharing their findings. Someone overlaid the data on a frequency graph, just to see what it would sound like. The result was unsettling, a soft, mechanical rhythm, like breathing under a layer of static. It didn't sound random. It sounded intentional. In one lab, a young astrophysicist stared at the waveform on her screen, whispering to herself, "It's talking." She didn't mean it literally. At least, she didn't think she did. But once the idea was spoken aloud, it spread like fire. What if this wasn't just light? What if it was a pattern, a message hidden in the glare. For days, teams around the world tried to find meaning in the pulse. They stretched the signal, inverted it, slowed it down. They searched for prime sequences, harmonic ratios, any sign that the rhythm contained structure. Some claimed to see shapes forming in the data, geometric imprints buried within the noise. Others warned against reading too much into it. They said it was rotation. Simple physics. A natural tumbling effect amplified by reflectivity. That explanation should have made sense, but it didn't. The pulse was too clean. Too perfect. In space, chaos is normal. But 3I/Atlas was too calm. Night after night, the pattern held steady. The pulses remained synchronized even as the object drifted closer to the sun. Its brightness should have flickered wildly as gases burned away. Instead, it grew sharper, like the pulse itself was stabilizing. By the third week, something strange happened. The pulse began to change. Not by much, just a fraction of a second faster. But it was enough for every observatory to notice. The interval shortened to 7.19 seconds, then 7.18. It was as if something inside the object was adjusting its rhythm, reacting to something. In Antarctica, the cold air outside the research dome was still and endless, and one scientist stood beneath it, staring up at a sky that never truly went dark. He watched that tiny point of light near the sun's edge and wondered if it could see him too. He thought about the distance, billions of kilometers, and how a pulse of light from that far away could still feel personal. Almost human. Reports began to surface online, unofficial and anonymous, claiming that the pulse had been detected not just optically but across different spectra, radio, infrared, even ultraviolet. If true, it meant the signal wasn't just reflection. It was emission. Something was creating it. The news spread quietly. No official statement. No confirmation. But once the data leaked, it couldn't be contained. Forums lit up with speculation. Some called it a cosmic coincidence. Others used words no scientist wanted to say out loud, words like artificial or intelligent. For every skeptic, there was someone who looked at the graphs and felt the same unease. This didn't look like nature. The pulse kept repeating, like a question being asked again and again in a language no one understood. And every time it flashed, Earth answered, not with words, but with curiosity, confusion, and a quiet sense of fear. Because if this was a signal, then it meant someone, or something, was out there sending it. But even stranger was what came next. As 3I/Atlas neared its closest point to the sun, the pulse weakened, only slightly, but enough to notice. Then, without warning, it vanished. The light curve flattened. The rhythm stopped. Instruments showed nothing but static. It was as if someone had flipped a switch and cut the connection. Silence. At first, scientists thought they'd lost the signal due to solar interference. But when they recalibrated and checked the secondary feeds, everything else was normal. The sun was stable. The instruments were fine. Only 3I/Atlas had gone quiet. For 2 full days, nothing. Then, just as suddenly, the pulse returned. Louder. Brighter. Faster. It was no longer 7.2 seconds. It was 6. Perfectly timed. Perfectly deliberate. That change terrified people more than anything before. Because it didn't just mean the pulse was still there, it meant it had evolved. Something about the silence in between had changed it. Maybe it had learned. Maybe it had adjusted. Maybe it was waiting for us to notice. No one could agree on what was happening, but everyone agreed on one thing: this was no random flicker. It was a pattern. A message carved into light. A heartbeat echoing through space. And now, for the first time, it felt like that heartbeat was aware of us. What was once a distant object, a rock, a comet, an interstellar traveler, now felt like something else entirely. Something that could see. Something that could respond. The pulse in the dark had become a voice. And whether we were ready or not, it had just started speaking. It began with heat, a kind of heat that shouldn't exist. When the Solar Dynamics Observatory turned its gaze toward 3I/Atlas, it wasn't looking for anything unusual. By all accounts, it should have behaved like any other interstellar fragment, cold, inert, predictable. But what the instruments detected didn't belong to any model of physics we know. Across the surface of 3I/Atlas, the temperature wasn't stable. It rose and fell in perfect waves, synchronized, deliberate, alive. The heat moved like a current, flowing from one hemisphere to another, pulsing every 7.2 seconds. The same rhythm as the light. At first, the scientists thought it was a calibration issue. Maybe sunlight scattering off the solar panels, maybe an atmospheric glitch. But as the data came in from multiple observatories, the pattern held true. Every reading matched. Every pulse of light carried a corresponding rise in temperature. Heat and light, perfectly in sync. That's not how nature works. In space, heat doesn't dance to a rhythm. It doesn't move unless something moves it. Yet here was an object doing exactly that, as if it understood the energy flowing through it, and was using it. The numbers told a story that no one wanted to believe. When 3I/Atlas brightened, its temperature spiked. But not from solar radiation, the increase came from within. A pulse of internal energy that traveled across its body like breath through a living thing. And then it cooled again, waiting for the next beat. Over and over, the cycle repeated. 7.2 seconds. Then 7.1. Then 7. Each time, the heat pattern grew sharper, more refined. Almost efficient. The lead thermal analyst at NASA described it in one quiet sentence during a late-night press call that was never released to the public: "It's redistributing energy like a machine." That phrase, "like a machine," changed everything. The idea was impossible. 3I/Atlas was supposed to be a natural object, drifting for eons through interstellar space. A relic, not a reactor. Yet, every sensor now said otherwise. Infrared maps revealed something extraordinary: localized hotspots forming geometric shapes across its surface. Hexagonal, sometimes linear, always symmetrical. One side would heat rapidly while the other cooled, balancing out the total output to remain nearly constant. It wasn't random. It was control. As the days passed, 3I/Atlas drew closer to the sun. The light around it flared and scattered, but its core temperature stayed almost unnervingly stable. It was as if the object was adapting, redirecting energy away from vulnerable zones, protecting itself. Something about that behavior felt intentional. Almost defensive. When solar winds hit, it didn't react like dust or ice. Instead, its temperature dropped, just before impact. Then, once the radiation passed, it surged again. The readings were precise to the second, every movement in sync with that accelerating rhythm, the same pulse of light detected weeks before. It was no longer 7.2 seconds. Now it was 6.8. Then 6.5. Each cycle growing faster, tighter, stronger. The connection between light and heat became undeniable. One scientist called it the heartbeat of a machine. Another, more poetic, said it looked like something dreaming beneath its shell. No one could explain how it was happening. The surface was too small to support internal convection, too smooth to create natural thermal waves. Even the composition didn't fit any known material. Its reflectivity was strange, metallic but not quite metal. Crystalline, perhaps. Artificial, maybe. In private channels, researchers started whispering theories they'd never dare publish. What if the object wasn't just reflecting sunlight, but harvesting it? What if the pulses weren't just signals, but part of a system, an engine? The thought was terrifying. Because if that were true, it meant the object wasn't merely passing through our system. It was doing something while it was here. One night, as the observatory data streamed in from multiple satellites, analysts noticed something else. The thermal pulse wasn't just reacting to the sun, it was responding to observation. Each time an instrument locked onto it, the temperature shifted. Only by a fraction, but consistently. As if it could feel the attention. The coincidence was too specific to ignore. Could a natural body detect when it was being watched? Of course not. But then again, nothing about 3I/Atlas was behaving naturally anymore. Soon, the pulse changed again, faster now, almost frantic. The intervals shortened to 6 seconds, then 5.9. And with each cycle, the heat spike spread farther across its surface. The whole object began to shimmer with thermal distortion, like a living ember twisting in space. Spectral readings captured an unusual signature, faint, repeating bands that looked like encoded patterns within the infrared. Some described it as a waveform. Others, a pulse train. Whatever it wasn't random. And the strangest part? When scientists isolated the waveform and plotted it visually, it resembled a structure, lines crossing in patterns too orderly for chance. Some saw a grid. Others saw symbols. But everyone agreed, there was information hidden inside the heat. At this point, disbelief turned into something deeper, unease. The object wasn't breaking apart as it neared the sun. It wasn't evaporating like a comet. It was stabilizing. Reinforcing itself. Every pulse, every thermal shift seemed to strengthen it. It was as if 3I/Atlas had entered some kind of preparation phase. A transformation. And then, silence. Just as before, the pattern stopped. The light went flat. The heat readings vanished. For hours, there was nothing but static. Teams rushed to check their instruments, fearing system failure. But all systems were normal. The sun was quiet. Space was calm. Only 3I/Atlas had gone dark. When the signal returned, it came with something no one expected, a massive burst of infrared radiation, brief but powerful enough to saturate sensors across 3 continents. And buried inside that burst was a frequency. A repeating tone. It lasted less than 4 seconds, and then it was gone. Some said it was interference. Others called it a coincidence. But for those who'd been watching closely, the meaning was clear. The object wasn't just emitting energy. It was transmitting it. Whether it was by accident or design, no one could say. But one thing was certain, the pattern of heat, the so-called heartbeat of 3I/Atlas, was no longer random. It was responding. And whatever was controlling it, had just made contact. The next question was no longer what 3I/Atlas was. It was who, or what kind of intelligence, could build something that survived the sun. And somewhere deep in that silent rhythm of heat and light, humanity began to realize something profound. We were no longer just observing the universe. The universe might be observing us. It was supposed to be predictable. At perihelion, the point where 3I/Atlas would swing closest to the sun, astronomers expected one thing, brightness. The ice would vaporize, the dust would scatter, and light from the sun would bounce off its surface like it always does. Simple physics. But when the moment finally came, it wasn't simple anymore. The object didn't just brighten. It flared. Its reflectivity, its albedo, almost doubled in a matter of hours. Across every observatory, screens lit up with numbers that made no sense. An object that should have been faint and dying was suddenly shining with the intensity of something alive. It was as if the sun itself was being mirrored back, concentrated, refined, and redirected. At first, scientists blamed the instruments. Too much glare. Sensor overload. Maybe a software glitch. But after recalibrations, after cross-checking the data from multiple points on Earth and in orbit, the results stayed the same. 3I/Atlas had become too bright to be natural. Its surface, once dull and rocky, now reflected light like polished metal. And yet, it was still venting gas, still releasing dust, just like a comet. That shouldn't be possible. You can't have both. You can't be metal and ice. You can't reflect light like steel and still breathe like a living comet. But 3I/Atlas did. The spectral readings were even stranger. Instead of pure rock and frozen carbon compounds, the instruments picked up traces of nickel, magnesium, and something else, a reflective alloy that didn't match anything we've seen in nature. Whatever covered that surface was engineered by conditions we don't yet understand. When one research team plotted the object's brightness against time, they noticed a pattern. The peaks and troughs of reflectivity didn't just fluctuate randomly. They pulsed, matching, once again, the same rhythm as the light and heat signals detected earlier. 7 seconds. 6.8. 6.5. Each pulse growing faster. Each reflection more deliberate. It was as if the object wasn't just reflecting light, it was controlling it. Imagine a mirror that decides when to shine. That's what it looked like. A living surface, tuning its brightness in sync with an internal rhythm, almost as though responding to something unseen. One observatory in Chile tried a simple test. During the next observation window, they dimmed their instruments and tracked how the light intensity changed. What they saw left them speechless, as if 3I/Atlas had adjusted its brightness in real time, reducing glare just enough to keep itself visible. No one wanted to say it out loud, but the thought was there, hanging in every quiet lab. It's watching us back. The reflectivity wasn't just high, it was adaptive. When the sun's radiation intensified, 3I/Atlas became even brighter, as though using that energy to shield itself. But when solar winds weakened, it dimmed, almost resting. In thermal terms, this behavior made no sense. In human terms, it felt like awareness. When data from the European Space Agency came in, things got even stranger. The reflective spectrum wasn't consistent. Every few minutes, it shifted slightly, like a surface rearranging itself. A fluid layer of light and metal and vapor, changing phase faster than known chemistry allows. And yet, the deeper scientists looked, the more the numbers aligned. It wasn't random chaos. It was a process. An intentional one. By now, the international team had stopped referring to 3I/Atlas as just a comet. In closed reports, it had another name, a reflective body of unknown mechanism. Some believed it might be a natural form of self-regulating material, photonic shell, that evolved in interstellar space, able to balance heat by reflecting excess radiation. Others weren't so sure. Because that kind of precision doesn't come from chance. It comes from design. Even at its brightest, 3I/Atlas didn't behave like other objects near the sun. Most comets flare violently, shedding mass in a chaotic storm of dust and vapor. But this one, it flared smoothly. Consistently. The light was steady, clean, as if someone was dimming and brightening it with purpose. And then, another discovery shook everything. Spectrographic data revealed a series of narrowband reflections, tiny spikes of light repeating at precise wavelengths. Too regular to be natural. The pattern was eerily similar to reflected communication signals, the kind used by satellites when bouncing radio waves across long distances. But this wasn't a satellite. It wasn't supposed to know how to do that. Some thought it could be a coincidence, an interference pattern from solar radiation. But when the same signature appeared again, exactly aligned with the thermal pulse, it became impossible to ignore. Whatever 3I/Atlas was, it wasn't passive. It wasn't just reflecting sunlight. It was shaping it. Modulating it. And the more it brightened, the more the sense of unease grew among the teams watching. Because that brightness wasn't just a glow, it was information. When one astrophysicist isolated the data and inverted it, turning brightness into frequency, something chilling appeared. The variations weren't random noise. They formed repeating sequences. Almost binary. Light and dark. On and off. A code. But a code for what? The discovery was quietly archived. Officially, it was dismissed as data compression error. Unofficially, the files were encrypted and pulled from public servers. In the following days, the object's brightness reached its peak. It became visible to amateur astronomers, a silvery body flashing near the sun's limb, its glow unnaturally smooth. And then, without warning, the reflectivity dropped. Not gradually, instantly. The brightness collapsed by half in less than 2 minutes. Every sensor, every telescope, captured the same event. One moment, it was blazing like a mirror. The next, it was dull, matte, lifeless. It was as if the object had closed its eyes. No one could explain how that was possible. Not in terms of physics, not in terms of probability. Some said the surface had realigned. Others whispered that it was hiding. Whatever it was doing, it left behind one haunting question, one that no one could answer. If something out there can control light this precisely, what else can it do? As the sun's gravity pulled 3I/Atlas toward its tightest point of orbit, its temperature rose, but its brightness stayed strangely low, almost like it was conserving energy. Waiting. Scientists braced for disintegration, but part of them, the quiet, fearful part, wondered if this wasn't the end. Maybe this was just the beginning. Because an object that can think in light might not be burning. It might be transforming. And if that's true, then whatever 3I/Atlas becomes next, we're not ready to see it. It began with silence. After weeks of rhythmic light, of predictable pulses beating like a cosmic heart, 3I/Atlas suddenly went still. No warning. No fade out. Just, gone. The light curve flattened. The rhythmic pulses, those 7-second intervals that had haunted every observatory, vanished completely. On every screen, across every lab, the same flat line appeared. A straight horizon of nothingness. At first, people thought it was an error. A data dropout. Solar interference, maybe. But when the silence stretched on, minutes, then hours, then days, the truth began to sink in. 3I/Atlas wasn't emitting anymore. It had stopped. For the first time since its discovery, the universe felt quieter. Scientists stared at the data streams, waiting for something to happen. Some watched in disbelief, others in fear. They knew that in space, nothing ever truly stops. Energy always moves, radiation always hums. Even the quietest object still speaks in heat or motion. But this one didn't. It was like it was holding its breath. One astronomer from the European Southern Observatory described it perfectly. It feels like it knows we're watching, and it doesn't want to be seen. That idea spread faster than the data itself. Because the silence wasn't empty. It was intentional. When scientists zoomed into the noise, the faint static between readings, they noticed something strange. Deep in the lowest layers of the signal, below what instruments were designed to detect, there was movement. A faint modulation. Tiny, almost imperceptible ripples that shouldn't exist in pure silence. At first, they ignored it. It was background interference, maybe solar dust or electromagnetic noise from the instruments themselves. But the more they filtered the signal, the more the pattern held together. It wasn't random. Every 6.5 seconds, the same interval as the final known pulse, the noise would dip. Not visibly, not to the naked eye, but enough that advanced software could detect it. It was like a heartbeat buried under static. A whisper under the silence. That discovery sent a shiver through the entire research community. Because it meant 3I/Atlas hadn't stopped transmitting. It had changed how it spoke. It was no longer broadcasting light. It was hiding its signal beneath the noise floor, deeper than human instruments were designed to hear. Like it had learned how to disappear. Across different research centers, teams worked overnight to isolate the hidden signal. The data was faint, corrupted, incomplete. But once they filtered out the solar background, a pattern began to emerge, a slow, oscillating wave that carried something uncanny: structure. It wasn't the smooth randomness of natural noise. It had order. The intervals weren't perfect, but they were intentional. Each dip, each rise, repeated at measured intervals, with microscopic deviations that suggested information. Something was encoded inside the silence. When they sped it up, compressing hours of data into seconds, it made a sound. A low, uneven rhythm. Like breathing. In labs across the world, people listened to that sound in disbelief. It wasn't music. It wasn't a signal. It was something in between, something alive, hiding in the background of the cosmos. Some called it coincidence. Some called it madness. But one thing was certain: the silence wasn't empty anymore. And the object wasn't gone. If anything, it had gone deeper. It felt like 3I/Atlas was retreating into the shadows, pulling back just far enough to see who would follow. For days, the faint frequency drifted in and out, as though moving through layers of space we couldn't perceive. Sometimes it grew sharper, other times it dissolved entirely. Each time scientists thought they'd lost it, the signal would return, slightly altered, as if rewritten. It was adapting. The realization hit quietly, almost too softly to accept: it was listening. Every time new instruments were calibrated, every time new algorithms were applied to decode the pattern, the signal changed just enough to counter them. As though it was one step ahead. A kind of call and response, between us and something that didn't want to be found. NASA didn't make an official statement, but a leaked transcript from a private briefing revealed what some already suspected. The object's silence is not random. It's selective. It's communicating by absence. Communicating by absence. The phrase spread across the internet like wildfire. People began calling it the quiet code. It wasn't long before a small group of independent researchers tried mapping the fluctuations directly to binary data. What they found didn't form letters or symbols, but patterns that looked geometric, almost architectural. Lines intersecting in symmetrical shapes. Some saw a grid. Others, an orbit map. But one pattern stood out among all the noise, a curve that mirrored the shape of 3I/Atlas's trajectory itself. It was as if the object was describing its own path. And then, just as suddenly as it had vanished, the modulation shifted. The dips grew deeper, the noise grew quieter, and for a moment, the signal froze, like a pause between breaths. Then, one sharp spike. A single, perfect pulse. It was brief, less than half a second long, but it carried more energy than all the subtle modulations before it combined. It was a burst so clean that it cut straight through the static, visible to every observatory on Earth. And then, once again, silence. Not the hollow kind, the heavy kind. The kind that feels aware. After that, nothing. The buried frequency was gone. The static returned to true randomness. Whatever had been hiding beneath the noise, had left. No more pulses. No more modulations. Just space. Some say the object shut itself down, conserving power as it drifted away from the sun. Others believe it changed its method entirely, switching to something beyond our ability to perceive. But a few, the ones who stayed up long after the data feeds went dark, noticed something no one could explain. Every time the sun emitted a minor flare, the background static around 3I/Atlas would shift, almost imperceptibly. Like a ripple in a pond, answering back. It wasn't enough to prove anything. But it was enough to raise one haunting question. What if the silence itself is the message? What if, in going quiet, it's not hiding from us, but waiting for us to understand? Because sometimes, in science, as in life, the loudest truths don't shout. They whisper. And in the silence between signals, something out there is still listening. It started with a mistake, or at least, that's what everyone thought. A young researcher at the University of Tokyo had been assigned one of the smallest roles in a global project, to double-check the math. Nothing glamorous. Just cross-referencing pulse intervals from the 3I/Atlas dataset, a routine task buried beneath terabytes of numbers. But late one night, as the campus emptied and the city lights faded into the haze, she noticed something that didn't belong. The intervals between the light pulses weren't random. They formed ratios. Clean, consistent ratios. At first, she thought her software was glitching, maybe it was smoothing the data too perfectly. But when she ran it again, using a different model, the same thing appeared. Ratios that shouldn't exist in natural systems. She zoomed in on the pulse timings. 1, then 2, then 3, then 5. 7. 11. 13. Prime numbers. They repeated in perfect rhythm, over and over again, embedded within the intervals of the pulses themselves. Her hands trembled as she rechecked everything. The data sources. The timestamps. The solar corrections. But nothing changed. The pattern was real. She didn't sleep that night. She couldn't. Because deep down, she knew what prime sequences meant. Nature doesn't count in primes. Intelligence does. When she finally submitted her report, it set off a chain reaction that no one could stop. Within hours, global research channels lit up. The Japanese Space Agency confirmed her math. MIT verified it independently. And then, silence, the kind that only happens when the world realizes it might be looking at something it's not ready to understand. Prime numbers. From an object not of this solar system. It wasn't rotating. It wasn't venting gas. It wasn't behaving like any comet, asteroid, or interstellar debris ever observed. Something, or someone, had built it. The community split overnight. Some dismissed it immediately, calling it data misinterpretation, a coincidence magnified by overfitting algorithms. Others argued the odds were too small, the precision too clean. But there was one fact no one could deny: every test, every replication, every independent check kept leading to the same outcome. The ratios were there. Hidden in plain sight. One researcher from Caltech described it perfectly. It's not noise pretending to be order. It's order pretending to be noise. That sentence spread like wildfire. Because it captured exactly what 3I/Atlas had been doing from the start, hiding intention beneath randomness, logic beneath chaos. For months, scientists had struggled to explain its uneven heat distribution, its mirrored surface, its unpredictable silences. But now, everything seemed to point towards something chillingly consistent. The object was behaving like a machine. Not a ship. Not in the way science fiction imagines. But a device, something built to function, to observe, maybe even to communicate. The machine hypothesis. That's what they called it. And almost instantly, it tore the scientific world apart. Publicly, the big agencies stayed cautious. They released carefully worded statements about unexplained anomalies, data requiring further verification. But privately, behind encrypted meetings and late-night transmissions, everyone was asking the same question. If it is a machine, who built it? And why is it here? As the story broke across the media, old debates reignited. Some called it a probe, maybe an ancient artifact, drifting between stars for eons. Others said it was something more haunting, a fragment of technology from a civilization long gone, still carrying out a mission it no longer remembers. There was one chilling possibility few dared to speak aloud, that it wasn't just old, but waiting. The ratios didn't just match prime numbers. When converted into binary spacing, they formed clusters that resembled digital packets, bursts of data that could, theoretically, contain information. Like a broadcast designed to be noticed, but not understood. Somewhere in those intervals, between the 3 and the 7, between the 11 and the 13, something was hiding. Teams began to model it as a signal, stripping away the noise, amplifying the structure, feeding it through every decoding method known to science. The results were inconsistent, but one pattern kept reappearing, a fractal repetition of shapes. Not random. Geometric. It was almost as if the pulse itself carried a blueprint. Not a message. Not words. But structure. A shape repeating at different scales, small, then large, then small again. Like the echo of a design principle, imprinted in light. One physicist described it as a machine teaching by example. The thought sent chills through the entire research network. If 3I/Atlas was designed to teach, then it was never meant to go unnoticed. It wanted to be found. And maybe, it wanted us to learn something. But the deeper scientists dug, the stranger it became. The ratio started shifting slightly, almost imperceptibly, like the object was adjusting, responding to the attention it was receiving. Data from early observations no longer matched new recordings. The primes began to drift, not in sequence but in timing, as though something inside the object was recalibrating. It was reacting. That was the moment everything changed. Because if the primes were a message, and that message was changing, then whatever built it wasn't gone. It was active. Maybe not alive in the way we understand, but aware, in its own, cold, mathematical way. The machine hypothesis evolved into something darker. What if 3I/Atlas wasn't just an ancient relic, but a part of a system? A probe, designed to monitor, report, or even awaken something else. Every new discovery seemed to add more questions than answers. And yet, beneath the chaos, there was awe, a deep, quiet sense of wonder that humanity might not be alone in building machines that think. Somewhere, far beyond our reach, another intelligence once looked at the same stars we do now, and decided to send something into them. Not a greeting. Not a weapon. Something in between. Something that could outlast its makers. Something that could keep listening. And as 3I/Atlas drifted farther from the sun, its signal weakened, but its mystery only deepened. Scientists could no longer agree on what they were even studying, a machine, a relic, a message, or a mirror showing us the limits of our understanding. Because maybe, in trying to decode it, we weren't uncovering a signal at all. Maybe we were activating it. And if that's true, then one question remains. The one whispered in every late-night lab, in every quiet observatory where the data still flickers faintly on the screen. What happens, when the machine answers back? It started as a flicker, almost too subtle to notice. For years, scientists have watched the sun, charting its flares, mapping its corona, predicting its moods with painstaking precision. And for all that time, the sun behaved predictably, like a giant, simmering furnace, throwing off energy in its chaotic, beautiful, untamable way. But then 3I/Atlas came close. Not close, exactly, close enough to skim the outer edges of the corona, threading its way through a sea of plasma hotter than anything on Earth. And almost immediately, the sun began to react. At first, it looked like coincidence. A small flare here, a burst of solar wind there. The kind of fluctuations that happen every day. But as the hours passed, patterns emerged. Flares, enormous and violent, began to curve, not away from the object as physics would demand, but toward it. Magnetic loops stretched and twisted, aligning along the comet's trajectory, like the sun itself was bending, reaching, responding. Every pulse, every flare, every spike in solar activity matched the intervals 3I/Atlas had been showing for weeks. The rhythm, accelerating through its light and heat, now seemed to echo in the very heartbeat of the sun. No one had ever seen anything like it. At the Solar Dynamics Observatory, a team of researchers stared at the live feed, frozen. They could see plasma jets arcing toward the object. Solar prominences stretching unnaturally long, as if trying to touch it. Radiation bursts warped in strange, symmetrical ways. The data didn't make sense. Not by any model we have. It was as if the sun knew it was being observed. And somehow, it recognized 3I/Atlas. The realization sent ripples through the scientific community. At first, everyone questioned their eyes. Surely it was a measurement error. Surely solar models had gaps. But as data streamed in from satellites, observatories, and instruments around the globe, the pattern remained undeniable. The sun was reacting, purposefully. For decades, humanity has considered the sun a force of nature, massive, unthinking, indifferent. But now, it felt alive. Or at least, semi-aware. Capable of interacting with something that had come from another star. Some researchers whispered the word resonance. Others dared to go further. Recognition. The notion was unsettling. The sun itself, one of the oldest witnesses of the galaxy, appearing to respond to an interstellar object as though it were familiar, as though it had seen it before. Every flare that bent toward 3I/Atlas was timed perfectly with its light pulses. Every magnetic spike aligned with its thermal shifts. Even the brief silences of the object corresponded to moments of calm on the solar surface, as if the sun was holding its own breath, waiting. Across the world, scientists began comparing the intervals. 7.2 seconds, 6.8, 6.5, the same accelerating rhythm from light and heat now mirrored in solar activity. It wasn't a reaction in the usual sense. It was coordination. Some theorized that the comet's unusual composition, metallic surfaces combined with volatile ice, created electromagnetic fields strong enough to influence local solar plasma. Others argued that even that was impossible. The sun is too massive, too energetic, too chaotic to respond to an object of this size, and yet, it did. Observatories in Chile and Hawaii noticed something else. The flare patterns weren't just curving. They were targeted. Jets of plasma arced around magnetic field lines, tracing shapes in space that mirrored the object's path, almost like a signature written in fire and light. Every day, the sun seemed to pulse in rhythm with 3I/Atlas. Flare after flare, spike after spike, magnetic flux bending in perfect synchrony. And then, a team in Antarctica made a chilling observation. During one particularly close pass, a small coronal mass ejection, the kind that would normally send shockwaves away from the sun, instead split into two streams. One moved outward into space, harmless. The other, unerringly, followed the comet's trajectory, as though the sun was guiding it. For the first time, humanity witnessed a star behaving like an organism. Every graph, every thermal map, every spectrographic reading seemed to tell the same story. Something ancient and powerful was stirring. Something that had long existed in silence had now awakened to a familiar presence. The scientific papers flooded in, cautiously worded but impossible to ignore. Journals that had once dismissed interstellar anomalies were now publishing studies suggesting the sun's activity had been influenced, not just passively observed, but actively synchronized. Some scientists refused the idea outright. The sun can't respond. It's a nuclear furnace, a plasma sphere of gas and energy, indifferent to all. Yet the data couldn't be denied. For the first time, even skeptics paused. Even the most grounded astrophysicists admitted it. There was a connection here, a resonance, a communication written not in words, but in light, in heat, in magnetic storms. Outside the labs, humanity remained unaware. People watched the sun as usual, brilliant, unchanging, eternal. But above them, in the vastness of space, a quiet drama unfolded. A star and a traveler, ancient and alien, moving in rhythm with one another like dancers who had forgotten how long they had been apart. And then, just as abruptly as the flares had aligned, the sun quieted. The synchronized spikes ceased. Magnetic loops snapped back into place. Plasma jets straightened. The corona seemed to sigh and settle, as though the brief awakening had ended. 3I/Atlas continued its journey. Light pulses, heat shifts, and reflective flares now seemed distant, removed from the sun's direct influence. But the impression remained. Something had changed. The sun itself had reacted. And for a fleeting moment, humanity glimpsed the possibility that the universe is more than random motion. That even a star, a force we have always assumed was blind and indifferent, could acknowledge something foreign, could respond to an interloper with a precision that felt almost intelligent. Scientists sat in stunned silence, data screens glowing in the dark rooms of their observatories. They realized that the object wasn't just passing through space. It was interacting with one of the oldest, most powerful forces in the galaxy. And if it could do that, if a comet-like object could influence a star in ways our physics struggles to explain, then what else might it be capable of? The sun, for all its fury, its heat, its unimaginable power, had responded to something small. Something foreign. Something that shouldn't have mattered. And yet it did. In the quiet aftermath, as instruments recorded nothing but normal solar activity once more, a single thought lingered in the minds of those who had watched. This wasn't just a visit from an interstellar object. This was a recognition. The sun had awakened to 3I/Atlas. And somewhere deep in the cosmos, that recognition carried a question that humanity had yet to understand. Who, or what, had set this ancient dance in motion? Hours passed in silence. The flare of perihelion had faded, and the sun had settled back into its steady rhythm. Observatories returned to routine monitoring. And for a brief moment, it seemed that 3I/Atlas would leave the solar system like any other interstellar traveler, a fleeting visitor, soon gone, leaving nothing behind. But then, the echo appeared. It was subtle at first, buried in the hum of electromagnetic noise. Only the most sensitive instruments could detect it, a faint ripple radiating outward from the object, moving across space in waves that shouldn't exist. It was like a faint heartbeat, delayed, echoing across the ecliptic, traveling silently through the void. Researchers stared at the data, disbelief spreading across rooms filled with glowing monitors. The signal wasn't random. It had structure, precise, repeating waveforms that mirrored themselves in ways that no natural phenomenon could explain. And then the impossible became apparent. When the echo was overlaid with the cosmic microwave background, the faint afterglow of the universe itself, it aligned. Patterns emerged, faint but unmistakable. The waveforms from 3I/Atlas echoed in the oldest light in existence, as if it were speaking across billions of years and trillions of miles. It was not just passing through space. It was communicating with it. No one knew what to call it. A signal? A reflection? A deliberate imprint? It was all of those things, and yet none. The object, this small traveler, had somehow found a way to leave its signature on the very fabric of the cosmos. Teams across the globe began poring over the data. Some theorists suggested the echo was a byproduct of the object's unusual composition, metallic surfaces and volatile ice interacting with solar radiation to produce electromagnetic artifacts. But when simulations were run, the echoes refused to be replicated. The waveform persisted, precise and consistent, beyond any model humanity could create. It was deliberate. And haunting. The more they studied it, the stranger it became. The waveforms weren't just repeating, they were symmetrical, like a mirrored message stretching across space. Peaks and troughs formed patterns, almost geometric, almost intentional. The intervals carried the same accelerating rhythm that 3I/Atlas had shown in light, heat, and reflective pulses, the same pattern that had once synchronized with the sun itself. It was a voice made of physics. A whisper made of light and energy. And for the first time, humanity realized that 3I/Atlas might not only be a visitor, it might be a participant. Some researchers began to ask terrifying questions in hushed voices. Could this be a method of communication? Not just to us, but to the universe itself. Was the object conversing with distant stars, with the remnants of ancient civilizations, with the cosmic background that has existed since the Big Bang? The idea was impossible, and yet, the evidence refused to be ignored. For hours, teams worked feverishly, tracking the echo as it expanded across instruments. Every observation confirmed it, the signal propagated outward, fading with distance but never truly disappearing. And everywhere it traveled, it left a repeating imprint, a ghost of the object's own pulse, mirrored in the most ancient light in existence. At one point, a young astrophysicist in Berlin leaned back in her chair and whispered to her colleagues, "It's speaking, in the oldest language in the universe." No one laughed. No one disputed it. Because in that moment, staring at the lines and graphs, watching the waveforms trace themselves across the cosmic microwave background, it felt true. 3I/Atlas wasn't just moving through space. It was leaving a trace. A mark. A signal meant to last far longer than its brief visit to our solar system. The echo's persistence suggested intelligence. Not intelligence like ours, not emotional, not conscious in the human sense, but intelligence built on patterns, rhythms, and longevity. Every pulse, every mirrored waveform, was a testament to planning, to foresight, to purpose. And then, as researchers watched, the echo shifted. A tiny deviation appeared, a subtle acceleration in the wave's timing, perfectly aligned with the final thermal pulses recorded during perihelion. It was as if 3I/Atlas had remembered its own passage, encoding it into the waves it sent outward, leaving a self-portrait for the universe. Some whispered that the object had created a legacy, a message meant for anyone, or anything, capable of reading it. A mark that might be discovered millions of years from now, when the stars had moved, the solar system was long gone, and yet this tiny traveler's story remained embedded in the fabric of space itself. The thought was overwhelming. Humanity had stared at the cosmos for millennia, mapping planets, tracing light from distant stars, deciphering the echoes of the Big Bang. And now, for the first time, the universe itself seemed to answer back, not in words, but in rhythm, in structure, in pulse. The echo was proof that 3I/Atlas had touched more than space. It had touched time. It had reached across the cosmic eons and whispered in the quiet language of physics. For some, the implications were exhilarating. For others, terrifying. If an object could leave such a mark, could influence the sun, leave a signature in the cosmic microwave background, what else might it do? What other intelligence, hidden in the void, could be listening, watching, waiting? No one could answer. Not yet. The echo expanded outward, fading, becoming part of the background noise of the universe. But in labs around the world, in the quiet hum of computers and the blinking of instruments, the realization settled in like a slow wave. Humanity had seen something new. Something ancient. Something alive in the language of energy itself. 3I/Atlas had not come to visit us in the usual sense. It had come to leave a mark, a conversation written in the universe's oldest medium. And somewhere, beyond comprehension, the cosmos had listened. As the data streams returned to normal, as screens finally stopped flickering with the faint pulses, a single truth remained: the object had gone, but its echo would endure forever. And for the first time, scientists began to understand something profound. Sometimes, the universe doesn't just exist. Sometimes, it responds. And sometimes, it remembers. Then, just like that, it stopped. After weeks of pulses, flares, and whispers of electromagnetic echoes, the instruments went silent. Not a gradual fade. Not a temporary glitch. Just, nothing. At first, scientists thought it was a technical issue. Maybe a satellite malfunction. Maybe a solar storm had fried the sensors. But the more they checked, the more impossible it became. NASA's solar probe flagged signal contamination. European servers went dark. Data streams that had been flowing for hours vanished mid-transmission, leaving blank lines where cosmic revelations had once been. In labs across the world, monitors flickered, then froze. Screens that had once been alive with the heartbeat of an interstellar visitor now stared back empty, reflecting only the quiet panic of the teams behind them. And then the quiet directive came. Not a press release. Not an announcement. A simple, almost invisible instruction: cease public discussion. Do not release further data. Keep the details contained. For the first time, humanity was asked to step back. To stop looking. To stop asking questions. Officially, it was framed as a precaution. Data integrity. Instrument calibration. Classified scientific procedure. Unofficially, people whispered. Some said the object's behavior had surpassed what humans were ready to understand. Others said it wasn't safe to let the public see what had happened. But the universe doesn't care about directives. Amateur astronomers, armed with backyard telescopes and determination, refused to comply. They kept watching. They tracked 3I/Atlas as it moved slowly away from the sun, skimming past planetary orbits, and every observation confirmed one thing: it wasn't leaving the system. Not in the way anyone expected. It lingered. Hovering. Meandering. Sometimes following trajectories that looked deliberate, almost like it was tracing invisible lines across the solar plane. Every measurement, every calculation suggested it was staying just long enough to be seen, just long enough to leave a mark. Observers reported strange behavior. The light pulses returned, faint, almost ghostly, flickering in intervals that no one could predict. Thermal readings showed subtle shifts, consistent with past rhythms. And somehow, despite the lack of official data, the object seemed aware, responsive to the tools trained on it. It was as if 3I/Atlas knew the world was watching, and it didn't care about the rules anymore. Inside research centers, the atmosphere turned tense. Teams argued quietly, fiercely, over interpretation. Was the shutdown a protective measure by the agencies? Or was something else controlling access to the data? Some feared the former, some the latter. But all agreed on one fact: the object had become untouchable, almost like it had activated a lockout. One astrophysicist described it like this: it's as if the universe pressed pause. Someone, or something, decided we weren't ready. The thought was chilling. For the public, the directive created silence. Media reports were sparse, vague, and quickly buried under unrelated headlines. But online communities, amateur forums, and private groups kept the story alive. They tracked it tirelessly, noting every tiny flicker, every unaccounted deviation in its trajectory. And the more they observed, the more 3I/Atlas defied expectation. It wasn't escaping the solar system. It wasn't plunging sunward or being slingshot out. It was staying in the outer reaches, moving with a slow, deliberate grace, lingering in ways that no natural object ever had. The amateur observations began to reveal patterns, tiny, almost imperceptible deviations in speed and angle. Some speculated it was surveying planets. Others suggested it was mapping gravitational fields. But no explanation fit perfectly. The motion was deliberate, but not mechanical. Calculated, but not predictable. Meanwhile, the official silence deepened. Data access was restricted. International research centers exchanged terse communications, careful to avoid public leaks. Some teams reported internal disagreements, heated debates over whether to obey the directive or continue sharing findings. Others quietly stored data offline, afraid to delete what might become critical evidence. The sense of isolation was palpable. Scientists were studying a phenomenon that had already surpassed human comprehension, yet they were being asked to stop talking about it. And then came the moments that no instrument could fully explain. Observers noted reflective flashes, brief, intense glimmers that did not match the object's known albedo. The spikes of light seemed timed, almost responding to human observation. Flares that had once followed solar activity now appeared in isolation, detached, deliberate. 3I/Atlas was still active. Still alive in its own mysterious way. And yet, entirely out of reach. For the first time, humanity had met an object it could not fully measure, control, or report. The data lockout was more than bureaucratic precaution, it felt like a warning. Some whispered that the directive was precautionary, meant to prevent panic. Others suggested something more, that the object itself had influenced the flow of information, deciding who could see, who could know, and who could not. The boundary between agency and object blurred. The more the amateurs documented its movements, the more precise their records became, almost as if 3i/Atlas was cooperating with some, but defying others. Night after night, backyard telescopes across the globe recorded the faint pulses. Communities shared data, compared notes, and pieced together a patchwork image of an object defying classification. Some claimed it was slowing, adjusting, or even responding to Earth's orbital motion. Others noticed subtle reflective variations, light signatures that repeated across nights, mirroring sequences previously observed during perihelion. And yet, despite this growing grassroots understanding, the official channels remained closed. Data was locked away, files encrypted, servers silent. What humanity could see was only a fraction of what existed. It created a strange tension. Scientists worked in shadows, while amateur observers became the unexpected keepers of knowledge. And all the while, 3i/Atlas drifted onward, indifferent, patient, as though measuring who watched and who obeyed. The quiet consensus began to form in whispers: this was no ordinary object. It wasn't just interstellar debris. It wasn't just a comet or a rock or ice. Something about it was deliberate, intelligent in a way humanity couldn't fully grasp. And now, with the data locked, it was almost taunting us. Because the object hadn't left. It lingered, skimming planetary orbits, reflecting sunlight in faint, cryptic bursts. Its presence was undeniable, even as the channels to study it professionally were cut. Every calculation, every observation hinted at behavior that was purposeful, coordinated, and aware. The solar system itself became the stage, and humanity was barred from the main performance. And in the silence of official labs, in the hush of global observatories, the unspoken question grew louder than ever: if it wasn't leaving, then what was it waiting for? Because 3i/Atlas had shown the world something fundamental. Not just that interstellar visitors could reach our system. Not just that they could influence the sun. Not just that they could leave a mark in cosmic background radiation. But that they could decide who sees, who knows, and who remains in the dark. And as amateur astronomers continued to track it, night after night, it became clear: no matter how much humanity tried to control information, some truths cannot be contained. The object was still there. Watching. Moving. Waiting. And the world was learning that sometimes, the universe has its own rules. Weeks had passed since the data lockout. Silence had settled over professional observatories, and the world had mostly moved on, thinking the interstellar visitor was gone. But space doesn't forget. And it certainly doesn't stop. Then the faint pulses returned. Not just from one point, but from many. Across the sky, deep space arrays in remote deserts and high mountains detected tiny blips, flickers of electromagnetic energy that seemed almost alive. At first, the signals were dismissed as noise, cosmic interference, or the inevitable static of a universe filled with radiation. But the pattern became unmistakable. It was the same pattern. The same accelerating rhythm. The same primes, the same mirrored waveforms that had haunted the early observations of 3i/Atlas. Every pulse carried the signature of the object we had first welcomed with curiosity and fear. And now, it was everywhere. Signals appeared from multiple points across the sky, spread along the ecliptic, as if the object, or the intelligence behind it, had multiplied, fragmenting into different sources, scattering across the vastness of space. Some researchers whispered the impossible: perhaps 3i/Atlas had created copies of itself. Others suggested something even more unsettling, that something had answered, a distant intelligence reaching back in kind, responding to the original visitor. Every pulse was converging. Not randomly, but purposefully, methodically. Each one traced a path toward a single point, a coordinate that hovered near Earth's orbital track. The convergence was subtle at first, then unmistakable, like a slow tide rising in the deep void. For astronomers who had followed every twist and flicker of the object, the sight was electrifying. It was as if the universe itself had begun to speak in a language we barely understood, and now all voices were harmonizing into a chorus. From observatories in Chile to arrays in the frozen deserts of Antarctica, teams raced to track the signals. Computers struggled to map them in real time. Simulations were run, then rerun, and each time the outcome defied expectation. The pulses weren't just moving toward Earth, they were accelerating, converging with near-perfect coordination, as if guided by an unseen hand. The idea that 3I/Atlas could have multiplied seemed improbable. A single interstellar object could do many things, but duplication across interstellar distances? Beyond the boundaries of known physics. And yet, here it was, happening in the data, undeniable, staring scientists in the face. Some began to entertain even stranger possibilities. What if this wasn't a physical multiplication at all? What if the signals were a network, an echo, a distributed message from a consciousness that had once inhabited the object? Every pulse, every convergence, was part of a larger design. The more the pulses were studied, the more intricate the pattern became. Subtle variations in timing, slight phase shifts, mirrored waveforms, it was almost as if the signal itself contained instructions. And then came the moment that sent chills down the spines of every researcher. When the pulses neared the coordinate, they began to form a geometric pattern in space. Triangles, lines, arcs that stretched across millions of kilometers, all pointing to a precise location along Earth's orbit. The data was clear, something was directing these signals toward our planet's path. The implications were impossible to ignore. It wasn't a random visit. It wasn't chance. 3I/Atlas, or whatever had answered it, was aiming for Earth's orbital neighborhood. The pattern was too precise, too coordinated, too intentional to be accidental. And yet, there was no threat in the signals. No weapons. No destructive energy. Just pulses, deliberate, rhythmic, insistent. Like a heartbeat echoing across the void. The world's attention shifted quietly at first. Researchers debated how to interpret the signals without causing panic. Governments began monitoring privately, quietly, while amateur astronomers shared observations openly, connecting dots that professional networks could no longer discuss. The convergence became a puzzle, a cosmic riddle unfolding in real time. As the pulses drew closer along the ecliptic, it became clear that the event wasn't a simple continuation of 3I/Atlas's path. The object, or its progeny, was signaling intentionally. Each pulse seemed aware of the others, adjusting its timing, maintaining perfect rhythm, converging with uncanny precision. It was no longer just an interstellar visitor. It had become a system. A pattern. A message in motion. Some scientists described it as a cosmic choreography, a performance designed not for us, but along paths we could see and measure. Every movement carried information, encoded in a language of primes, mirrored waveforms, and accelerating pulses that stretched across space. And all of it pointed toward a single destination. Humanity could watch, calculate, predict, but we could not fully understand. The deeper researchers dove, the more the pattern resisted simplification. It seemed to anticipate our instruments, our methods, even our assumptions. The pulses adjusted as observations were made, a subtle feedback between the observers and the observed. It was awakening. Not like an animal, not like a human, but like a system realizing its influence, extending its reach across the void, converging toward a target it had chosen long before we even noticed. The realization settled like ice in the minds of those who studied it. Whatever was behind the pulses, whatever force or intelligence had orchestrated this pattern, it was aware, deliberate, and patient. It had waited decades, centuries, perhaps millennia, and now its presence was unmistakable. And yet, even with all the converging signals, all the precision and coordination, there was no overt contact. No voice, no landing, no arrival. Only pulses, quiet and insistent, building tension with every passing day. Amateur astronomers, armed with backyard telescopes and shared knowledge, became humanity's eyes. They charted the converging signals, mapped the ecliptic coordinates, and watched as the invisible geometry of the universe began to fold in on itself, drawing lines and shapes we had never seen before. Every night, the sky hummed with the faint echoes of 3I/Atlas and whatever had responded. Each pulse a note, each sequence a phrase, together forming a symphony we could not yet comprehend. The pattern was awakening, and with it, a new understanding of our place in the cosmos began to emerge. 3I/Atlas had arrived as a visitor. It had become a messenger. And now, weeks later, its influence was unmistakable. Something was converging, something had answered, and the universe itself seemed to be aware of our orbit. All eyes turned skyward. Every calculation, every simulation, every observation pointed toward the same undeniable truth: the pattern was deliberate, intelligent, and patient. And the convergence was no accident. For the first time, humanity faced a realization that was both exhilarating and terrifying: we were not simply observers. We were participants. The signals would meet at a coordinate near our orbital path, but what would happen then, no one knew. All that could be done was to watch. To wait. To wonder. And in that waiting, the sky itself felt alive. By the time official statements finally trickled out, the sky had gone still. Not a flicker, not a pulse, not a whisper of the electromagnetic echoes that had danced across the ecliptic for weeks. The instruments were quiet. The deep space arrays hummed with nothing but the familiar, cold static of the cosmos, the soundless backdrop of billions of stars and untold emptiness. For the first time in months, space felt like it had returned to normal. But normal had changed. Every telescope that had followed 3I/Atlas reported it. Not dramatic failures, not errors, not outright anomalies. Just a subtle drift in calibration, all by the same fraction, precise and consistent, as if every instrument had collectively shifted. Some dismissed it as thermal effects, or aging sensors, or minor cosmic interference. Others whispered something else entirely: maybe it wasn't the instruments that had changed. Maybe, perception had. Scientists checked and rechecked their readings. They recalibrated, reran models, and pored over logs. Every system, from the largest observatories in Chile to the small amateur setups in backyards across the world, reported the same thing: something had left an imprint. Not on the object itself, which had long since moved toward the outer reaches of the solar system, but on us, on the way we observe, on the very instruments we rely on to understand the universe. It was a subtle influence, almost imperceptible, but undeniable. A small nudge in the quiet. A gentle shift that said something beyond numbers and light curves. Something that suggested 3I/Atlas had left more than traces of its own passage. It had left a question. A feeling. A mark on the lens through which we see the stars. In the silence, the universe seemed to breathe. The cold vacuum wasn't empty. It was aware. It was watching. It remembered. Every observer, from the most precise astronomers to the casual stargazers, felt it in their instruments, in their data, in the subtle way the night sky appeared a little deeper, a little more alive. And yet, there was nothing to see. No signals, no echoes, no light patterns. Only the lingering presence of what had been. It was like the universe had whispered a secret and then closed its mouth, leaving humanity to sit in the quiet, to wonder if the secret had been a gift, or a warning. Researchers compared notes in hushed tones. The same fraction of drift, the same subtle offset. And slowly, almost collectively, a realization began to take shape: 3I/Atlas had done something no one expected. It had passed through our solar system and touched more than just physical matter. It had touched understanding. It had shifted the way we perceive space itself, like a stone causing ripples not just on water, but in reality itself. The realization was unsettling. For months, the object had defied models, bent the sun's activity, sent pulses echoing across the cosmic microwave background, converged signals along Earth's orbit, and now, in its absence, it had altered the instruments of observation. The full sequence of events suggested intelligence, yes, but also something more profound. A presence. A shape of thought. A quiet pattern embedded in the universe, waiting for humanity to notice. Amateurs and professionals alike felt the emotional weight of it. Some described it as awe. Others, as fear. It wasn't an immediate danger. It wasn't screaming across the sky. But the quiet, precise, deliberate influence suggested patience on a scale we cannot fully comprehend. Something ancient, something that had traversed light years, had moved deliberately through our system, and now, it was gone. And yet, it lingered. Every telescope observer, every instrument operator, every scientist tracking the object reported the same thing: the measurements felt different. The calibration drift wasn't just a number, it was a sensation, a subtle reminder that the universe is not entirely neutral. That even in apparent silence, it is alive with memory, with awareness, with possibilities we are only beginning to grasp. At night, when the sky is darkest, when the stars shine cold and distant, there is a sense of presence that cannot be quantified. A feeling that someone, or something, is listening, watching, and remembering. The quiet is not emptiness. It is something else. Something that traces the echoes of what has passed, the pulses that once radiated along the ecliptic, the light that bent around the sun, the pattern of intelligence that briefly touched our solar system. 3I/Atlas is gone. The converging pulses have vanished. The echoes have faded. But the shape of its passage remains, written not in dust or ice, but in subtle shifts and impressions. In the instruments, in the data, in the perception of those who have watched. And that imprint is permanent. The universe feels closer now. Not because it has come nearer, but because it has revealed a fraction of itself. A glimpse into a hidden layer of reality, where objects are not just matter, but messengers, where silence can carry intention, where distance is not absence, but a medium of connection. And in that quiet, something remarkable becomes clear: the cosmos is not indifferent. It is not blind. It responds. It remembers. It waits. We may never fully understand it. We may never decode the complete message, the final purpose, the ultimate origin of 3I/Atlas. But its passage has changed us. Instruments calibrated to a new fraction, perceptions adjusted subtly, human curiosity stretched to the edges of imagination. The sky is still again, but it carries memory. It carries the traces of rhythm, of pulse, of a pattern that reached across the stars and touched our minds. The silence is not emptiness. It is a presence. And in that presence, humanity feels something new: humility, wonder, and the quiet awareness that we are part of a universe far more alive than we ever imagined. The instruments will keep drifting ever so slightly. The data will always carry hints of what was. And every observer, looking up at the night sky, may feel the same thing: that 3I/Atlas passed through our solar system not just as a visitor, but as a teacher. A reminder that even in stillness, there is communication. Even in absence, there is memory. Even in silence, there is shape. And the universe is listening. Waiting. Remembering.